Hi Gabby, this is Miss Sims. I'm just going to have a go at going through some of your paper. Now this is my kind of unchecked, I don't know what the answers are for these, so please just accept hopefully what workings I can do on this. So look, we've got that's right and this is right. And let's move on to question B. We've been told that the roots of the equation, so we're kind of working backwards on this one. You've been told that the roots are -2, and I would change this to 10/3. And we have to go back and find what those two brackets, the two factors are. So for example, in the question before this, you found the root here, these two roots, and now we've been given those and we've got to find what these two brackets could be here that equals 0. And then once we've found those, we can expand the brackets and work out, they've asked us what's the value of the coefficient. Coefficient is just the pronumeral, the letter of the alphabet that will come before the x's or are in our quadratic equation. So a coefficient is just another word for a pronumeral or a letter of the alphabet. So that's the coefficient P. Once we have the factorized form and we expand it, hopefully we'll come up with a P and a Q value. So what values could go in these brackets? If x is -2, it makes the bracket 0. So it's going to be, when x is -2, it'd have to be a +2 in this bracket. And in the other bracket, when x is 10/3, there must be a 3 in front of this, and that would be a -10 there. So now I've worked out my factors. I can expand it. 3x squared, that would make -4x minus 20 equals 0. And if I now am looking for the coefficient in front of the x squared is 3, so P equals 3, and my last coefficient there, or constant really, is Q equals -20. I hope that's right. And let's go on to the next question. I might have to put this into 2 videos. Okay. At the bottom of the page, I've missed the bottom of the page. You were given x equaling this bracketed amount here. So this is right, what you've got here. Now be careful here, because if I have 1 minus a squared, if I expand that, I get 1 minus 2a minus a squared. If I expand 1 plus a squared, it's going to be over 1 plus 2a plus a squared. So that's where you might have gone a bit wrong on this one. So, and then once I've expanded these a's and things, I just really want one fraction on the top and one fraction on the bottom. So this 1 here, I'm going to change and make it the same denominator as my fraction, so I can put it all over one fraction on the top and all over one fraction on the bottom. So let's see how that will work. So I have 1 minus, so on the top I have 1 minus 2a minus a squared, and 1 squared. And then on the bottom of my fraction, I'll do that in black. I have 1 plus 1 minus, same thing really, it's not, minus a squared, 1 plus 2a plus a squared. And this is kind of all in bracket here. Now I want to just make it one fraction on the top and one fraction on the bottom. So I'm going to change this to a common fraction. Let me have a common denominator will be 1 plus 2a plus a squared. So I've got to multiply the top and the bottom of my 1 by that denominator. So I'll have 1 plus 2a plus a squared. Now be careful, this is a minus in front of the bracket. So I'm getting rid of my bracket here. It's going to be a negative. We'll have to multiply everything in the bracket. So it's a minus 1, a negative, this is really a negative 1 in front of there. So I'm going to have negative 1 times a negative 2a will be a plus 2a and plus a squared on top. And then on the bottom, I'm going to make my denominator 1 plus 2a plus a squared. And so my 1 is going to be 1 plus 2a plus a squared. And then what's in the bracket? Plus 1 minus 2a minus a squared. So tidying these up, I have on my top I've got a 1 minus 1, so I can get rid of that. And I've got plus minus 1. I've got, did I get negative 1? Oh, I know what I did wrong here. Negative a times a negative a is a positive a there, and so that makes a positive a there, and so that would be a, sorry, I've messed up already on here, a negative a there, and so I've got a plus a squared and a minus a squared, which cancel each other. So on the top of that fraction is only left a 2a plus a 2a, which is a 4a, over 1 plus 2a plus a squared. And on the bottom of the fraction, I've got 1 plus 1, I've got 2, 2a minus 2a, and a squared minus, did I do that wrong too? Minus plus a squared. Yes. 1 minus a times 1 minus a, that should be a plus here, plus a squared. So plus 2a squareds over 1 plus 2a plus a squared. So I've got a blue fraction divided by a black fraction, and the easiest way to solve that is to multiply, take the denominator and turn it upside down, multiply by the reciprocal. So if I do that, I've got 4a over 1 plus 2a plus a squared, and I multiply it by 1 plus 2a plus a squared divided by 2 plus 2a squared. So then I can cancel that there is the same as that there. which leaves me with 4a over 2 plus 2a squared. And I could simplify that, divide everything by 2 on the top and 2 on the bottom, so it leaves me with 2a over 1 plus a squared as my answer. I hope that comes out right. But the tricky thing, I think, in this one was the minus, this red minus in front of the bracket. So it was actually a -1, a -1, which multiplies the top of that bracket of the fraction. So it changes those signs. Hope that makes sense. Right, the next one. Do we go down this page? Let's see. No. Next question will be on the next. Okay, writing this. Now, one thing to remember for this, if you have a square root of x is the same as x to the power of a half. So if you have a cube root of x is the same as x to the power of 1/3. So I've got p to the power of 1/6. And that I can rewrite the cube root as to the power of 1/3 equals q to the power of 1/2. So I have a power of a power, so I multiply them. So I have p to the power of 1/18 equals q to the power of 1/2. I want to get rid of the power of 1/18, so I'm going to multiply that side by 18 to the power of 18, but I must also multiply this side to the power of 18. So p is all I have left there, equals q, 18 divided by 2 to the power of 9. I hope that's right. Okay, down the page. Got any more? Yes. Oh dear. Prove that the square of any odd number decreased by 1 is divisible by 8. Okay, so they presumably mean whole numbers here. It's divisible, these kind of questions. Usually if we take n as, or x, we're talking about real numbers. So let's say our odd number, let's do it over somewhere, we're kind of run out of room. Our odd number, I'll do it in blue, is 2. Let's say we have an odd number, let our odd number be 2n, not sure +1 or -1. I'll use +1 here, and n is a real number. So if we have our odd number 2n plus 1 and we square it, square of any odd number, and it's decreased by 1, let's see if that becomes divisible by 8. So we have 2n plus 1 squared is going to be 4n squared plus 4n, sorry, we're going to end up with plus 4n plus 1 minus 1. So that's going to equal 4n squared plus 4n. Now, so that means this, which is divisible by 8, it's always divisible by 8 because we've got at least 2 lots of 4n here. One lot of 4n and another lot of 4n will be 8n, so it must be divisible by 8, and to check that, if n equals 1, we have our answer will equal 8. If n equals 2, 2 to the 4, 4 to 16, plus 8, this we get 24, which is divisible by 8. Okay, I think that's how we prove that one. It's not a very easy one. Let's look at the next. Okay, you got that one. And this one here, just a small mishap here. 16 to the power of a half would be the square root of 16, which would equal 4. But you've got 16 to the power of a quarter, so that's going to equal 2, but be careful, it could be a 2 or a negative 2 in front of that. So the answer here could be 2x squared, or it could be negative 2x squared, because negative 2 times negative 2 times negative 2 times negative 2 is also 16. So just watch those. Going down the page, we've got okay, this one looks a bit longer. I'll just do the workings on the bottom here maybe. So you had 1 over x plus a plus 1 over x plus b equals 2 over x. So you've got 3 different denominators here. So what I would do would be to make just one denominator on the bottom. It's the bottom that you want the same, so that you can just erase all the denominators and you're just left with the top. So I've got to multiply, my first fraction will be, I've got to multiply the bottom by x plus b and by x. And to make that all, I'm going to have x, and I'm going to have x plus a, and I'm going to have x plus b, all on the bottom here. And then I'm going to, the second fraction needs to be multiplied by x and by x plus a. And then to make this x, x plus a, x plus b, over here I need to multiply the top 2, x plus a, x plus b, like that. So then we've got the same denominator on both sides, so I can cancel that there. So I'm left with, on this side, I'll do it in black maybe, we've got x squared plus bx plus x squared, so make 2x squared plus ax equals, and on the other side I've got 2 lots of x squared plus 2xa plus 2xb plus 2ab. Anything the same that I can cancel. I've got 2x squared on both sides. I've got 1 lot of bx here, so I can cancel that, make that 1. I've got 1 lot of ax, I can make that 1. So now I'm trying to find x. So let me put negative 2ab on this side equals, now I've got an xa plus an xb. I'll put x out the front and a plus b because I want x by itself. So now let's divide that side by ab. A plus b, sorry, divide that side and divide this side by a plus b. And if I cancel those two, I'm then left with x. Okay, that's it. Okay, I'll stop this here, and the video's getting a bit long, so I'll stop it and I'll restart it on slide 6 on the next one. Thanks.